joining me on Fascinating Frontiers, episode 134, for July 17th, 2026. Some fascinating developments to cover today. Astronomers report signs of an atmosphere on a rocky world in the habitable zone 48 light-years away, a first for planets of its kind. Observations indicate the 48 light-year distant world may retain an atmosphere thick enough to be detected from Earth. The planet orbits in the conservative habitable zone of its red dwarf host. Follow-up spectroscopy is planned to determine atmospheric composition. The detection relies on transit photometry that measures subtle changes in starlight passing through any extended gaseous layer. Current data suggests the atmosphere could be denser than models previously predicted for planets of this size. Additional telescope time has been allocated to refine the signal. The detection of a possible atmosphere on LHS 1140b stands out because the planet is both rocky and lies in the conservative habitable zone. Transmission spectroscopy during transits can reveal absorption features if the atmosphere is thick enough to extend above the surface. Confirmation would make this world a priority target for future atmospheric studies. Current models suggest the signal strength is sufficient for detection with existing facilities if the envelope is sufficiently extended. Repeated transit observations will be needed to build statistical confidence in the result. What specific gases would you most want to look for first? If Earth were placed 48 light-years away, its atmosphere would span less than 1/10,000th the width of the star it orbits. Yet that sliver is exactly what astronomers measure. When a planet crosses its star, a tiny fraction of starlight filters through the upper atmosphere. Molecules there absorb specific wavelengths, imprinting a barcode on the spectrum that reaches our telescopes. The James Webb Space Telescope records these changes at precisions better than 100 parts per million, across dozens of transits, enough to distinguish between a bare rock and one wrapped in a detectable gaseous envelope. The surprising number is the scale. The signal from an Earth-sized atmosphere at that distance is equivalent to blocking an extra 0.01% of the star's light for a few hours. Temperature gradients within the atmosphere further modulate the depth of absorption lines, revealing whether the gas is heated from above or below. Yet even with that detection in hand, we still cannot tell whether the atmosphere is being continuously replenished by volcanic outgassing or is a remnant left over from formation. The next generation of extremely large ground-based telescopes may resolve this ambiguity by capturing higher resolution spectra during single transits. 4 Raptor engines failed to ignite at T0, triggering an immediate safe shutdown and scrub for the day. The vehicle remained on the pad with no damage reported after venting clouds of smoke and vapor. The test was meant to advance vehicle maneuverability while docked, a step required for future lunar departure burns under the Artemis architecture. SpaceX later identified the ignition sequence issue through post-scrub data review. This attempt marked the latest in a series of integrated flight tests aimed at proving the full stack for crewed lunar operations. Engineers will now analyze telemetry before scheduling the next window. Starship's next test flight keeps the program moving forward in parallel with other major efforts. SpaceX launched a Falcon 9 carrying the third Tranche 1 data transport mission for the Space Development Agency into low Earth orbit. The satellites will join an expanding constellation designed to move large volumes of data between orbit and the ground. This flight continues the steady cadence of operational missions that support the tracked Starship and Mars program by demonstrating reliable access to orbit while Starship development focuses on refueling and reuse milestones. The mission profile targeted a precise insertion that adds capacity for real-time relay between multiple orbital planes. Ground teams confirmed successful deployment shortly after separation from the second stage. Future launches in the same series are expected to complete the initial Tranche 1 architecture. Serbia signed the Artemis Accords in a ceremony at NASA headquarters, committing to peaceful and transparent lunar exploration practices. The country's ties to NASA date back to Apollo-era tracking support. This addition strengthens the international framework that underpins crewed landing schedules and gateway readiness tracked in the Artemis and the Moon program. Officials noted Serbia's long-standing technical contributions during early lunar missions. The signing ceremony highlighted shared commitments to data exchange and debris mitigation standards. Additional nations are expected to join in the coming months as lunar infrastructure planning advances. NASA confirmed the Dragonfly mission to Titan remains on track for launch no earlier than July 2028 aboard a Falcon Heavy. The nuclear-powered drone will explore multiple sites on the Moon's surface after arrival in the mid-2030s. The timeline keeps the mission aligned with broader outer planet exploration goals. Mission planners have finalized the rotorcraft's science instrument suite for in-situ chemical analysis. Arrival at Titan will enable repeated flights across varied terrain types. The spacecraft will rely on radioisotope power for extended surface operations. Observers in the Americas will see the Moon and Venus separated by roughly 6 degrees in the evening sky, with the Moon positioned lower left of the planet. The geometry offers a clear, naked-eye view of the inner planet against the lunar disk. No special equipment is required. The event occurs as Venus continues its evening apparition through the western sky. Binoculars can reveal the planet's phase if atmospheric conditions allow. Similar close approaches recur on predictable cycles tied to the synodic periods of both bodies. A new Sentinel-2 image shows the mudflats, beaches, and mangroves of the Bijagos archipelago in Western Africa. The data highlight tidal patterns that support large populations of migratory shorebirds and sea turtles. The scene demonstrates ongoing monitoring of coastal ecosystems from orbit. The archipelago's sediment dynamics appear clearly in the multispectral bands. Seasonal flooding influences the extent of exposed mudflats visible in the imagery. Continued observations will track changes in mangrove coverage over successive years. Researchers mapped the spectral signature of penguin guano across Antarctica to monitor population changes and food web dynamics at continental scale. The method reveals how shifting sea ice conditions affect breeding success. It is the first time satellite observations have captured these patterns over 3 decades. The Landsat archive provided consistent multispectral coverage despite changes in sensor generations. Guano reflectance peaks in specific visible and near-infrared bands allowed automated mapping. Results show regional differences in colony response to ice variability. New modeling suggests the 4 known planets orbiting the nearby red dwarf formed with little water ice. The result implies limited prospects for surface liquid water on these worlds. Additional radial velocity data are expected to refine the mass estimates. Formation simulations incorporated the star's low metallicity and close-in orbital architecture. The planets appear to have accreted primarily from dry inner disk material. Refined mass values will help constrain bulk densities and possible surface conditions. The telescope detected a massive companion whose orbit and thermal signature had been hidden by the system's bright debris disk. The discovery adds to the known architecture of this young planetary system. Further observations will map the planet's atmospheric properties. The planet's presence was confirmed through direct imaging after careful subtraction of disk light. Its mass and separation place it among the outer companions in the Beta Pictoris family. Additional epochs will help determine orbital parameters and dynamical interactions. Skyroot Aerospace has completed final preparations for the Vikram 1 launch from Sriharikota. The vehicle is designed to place small satellites into low Earth orbit. Success would mark the first orbital flight by an Indian private launcher. The rocket uses a combination of solid and liquid stages optimized for cost-effective small payload delivery. Pre-launch reviews confirmed all systems met flight criteria. The company aims to establish a regular cadence of commercial missions following this debut. 2 Starlink mini laser terminals will be installed on Orion to transmit high-resolution video during next year's crewed test flight. The system supplements existing communications and will provide live views of rendezvous and docking with commercial landers. The choice directly supports public engagement goals for the 2028 crewed lunar return. Laser links offer higher bandwidth than traditional radio systems for imagery downlink. Integration testing will occur during ground simulations before the mission. The terminals represent an early operational use of commercial laser comms on a crewed spacecraft. Both satellites have arrived at Europe's spaceport and are undergoing pre-flight checks. Flex will monitor plant fluorescence while Sentinel-3C continues ocean and land monitoring. The shared ride demonstrates efficient use of the Vega C vehicle for Earth science missions. Pre-launch inspections include verification of solar arrays and propulsion systems on each spacecraft. The September window aligns with optimal orbital insertion conditions for both payloads. Mission teams will conduct final integrated rehearsals before rollout to the pad. Next time, keep an eye on Starship's rescheduled flight window and the first results from the Vikram 1 debut. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. And before you go, this show is part of the Nera Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Shorts Time, your daily deep dive into everything Tesla. Find every show free at neranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at neranetwork.com/data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through